Let us understand the complete concept of finding domain and range of variety of functions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are discussing a very important test question. It is based on domain and range of functions. We have 4 examples, and I hope with these 4 examples, any student can do most of the questions on domain and range. So we are considering transform parent functions to understand the concept. As you can see, the first question relates to parabola, quadratic equation. Second one is a square root function, which looks like a square root, but you'll soon discover it is not really a square root function. Then we have a rational function and absolute value function. So once we understand how to work with these, your basic hurdles are over. You can watch more of my videos to master this particular topic of domain and range. So let's begin with question number 1 and its solution. We are given the function f of x, which is equal to 1 minus 2 x plus 3 whole square. Now this equation is in the vertex form, so you can always find the vertex, you can find the direction of opening, and these two things will help you write domain and range. But the difficulty here is that it's written in a different order, and that is why students normally, if they make mistake, they will make a mistake. So first step is to write it in the standard way, right? So we'll rewrite this equation in standard way as you always see, which is minus 2 times x plus 3 whole square plus 1. Now it makes more sense, right? Earlier it was kind of confusing. Now it's very simple. You see that this is a parabola which really opens down, right? So it's a parabola which opens down very clearly, right? Since we have this negative here, right? That means parabola opens down, and what we also notice is the vertex. We are writing vertex coordinates now. Can you tell me what are the coordinates for the vertex? Well, they are minus 3 and 1. Minus 3, what makes this 0? Minus 3 plus 3 is 0, and then you are left with 1. You see that? And definitely this coordinate point is maximum for this particular parabola. So the maximum is at minus 3 and the value is 1. Now it is very simple to write domain and range, right? Perfect. So let's write down the domain first. So I'm using D for domain, X the independent variable, right? And I'm using the set notation as we have in this particular question. So the question, as you know, is find domain and range of each function in set notation. So let me underline this word once again. Okay. So the domain is what? Can you write? For a parabola, there are no restrictions. It's a smooth curve and x belongs to real numbers. It's the domain. How about the range? So range was a tricky part. Now we know that y belongs to the real numbers. So this is the set notation, right? The curly bracket set of real numbers. That E which you see here is a Greek symbol, epsilon, which means belongs to in mathematics. Now, y belongs to real numbers where y is less than equal to the maximum value of 1. Is that clear to you? So that is how we get the solution of the very first one. I hope with this you have understood the concept, and if you get a function which is quadratic function in vertex form, you could write the domain and range. If the function is not given in vertex form, you could convert that using completing the squares method, perfect, or some other strategies. Perfect. So now I think first question is absolutely clear. Well, still, if you need help, you can always contact me on the email address given. Perfect. Let's now move on to question number 2. Now, question number 2 is a difficult test question. Let me write it in a red ink, right? So it is g of x is equal to square root of 4 minus x squared. Now, can you tell me what type of function it is? Well, let's find the domain first and then figure it out, right? Okay. So whenever you have something in radical, we know that part should always be non-negative. Non-negative means that 4 minus x squared should be greater than or equal to 0, not negative. Perfect. Now let's try to solve it. So we say 4 is greater than equal to x squared. Now that is the inequality, which is the most difficult inequality to solve. 4 is greater than x squared. It really means what? Well, we could do the square root on both sides, right? So if I do the square root, let me just show it here in green light color, right? So if I do the square root, right, both sides, then what happens? This is what we need to figure out. Okay, square root of 4 is very clear. It is 2. So 2 is greater than equal to square root of x squared. Now many students will write this as x, which is wrong. Square root is always positive, so it is absolute value of x. You get the idea. So that is the correct thing, and that's the reason why you get this question also wrong in your test. Okay, so when I say that 2 is greater than absolute value of x, means absolute value of x is less than 2. It means what? It means it is within plus or minus 2. You get the idea? So it really means that it is within plus or minus 2. So that becomes the domain for this particular function. You get the idea, right? Now you're wondering what kind of function is this, which is like x value between plus and minus 2. Well, if I carefully look into it, I could really sketch it. Let me sketch it to write the domain also, right? So if you substitute some values between plus and minus 2, you will get a semicircle. So it really represents a semicircle, right? So it is from minus 2 to plus 2. And if I put 0 here, then we get square root of 4, which is 2. Perfect. So we get a semicircle, and now it is very easy to write domain and range, correct? So you can now pause the video, write down domain and range. Perfect. So let's write down domain, right? So domain, we say d of x, independent variable. X belongs to real numbers, where it is between minus 2 to plus 2, both included, right? So we minus 2 plus minus. You get the idea, right? Okay. Now, how about the range? So the independent variable y represents the range. Y belongs to real numbers, of course. And y is what? Well, it is greater than 0, but less than 2, right? Both included. So we'll write this as 0, right? Y is greater than equal to, but less than equal to 2. So that becomes the range for this function. Is that clear to you? So this really is not a square root function. It is a semicircle, right? So let's make a note of this. We have a semicircle here. Now, very important to recognize the semicircle to get the right answer. I hope this concept is clear. Perfect. Now, if you really want to excel, master the subject, then you may contact me on this particular email. Most of my students are right there on top of the class getting awards and scholarships, and that's the reason, right? Okay, great. Let's move forward to question number 3 now, and we have a rational function. Now here also, there are a lot of difficulties. Domain is not difficult at all. So let me write down the function h of x first, which is given to us as x plus 2 over x plus 5. Clear? So of course, denominator is not equal to 0. So x plus 5 is not equal to 0, means x is not equal to minus 5. So that gives us the domain. Perfect. That gives us the domain. And the domain here is, that domain of this function is that set notation, right? X belongs to real numbers, but x is not equal to minus 5. Absolutely clear. Perfect. No doubt about it. Now the question is, how do I write range of this function? What are the y values? They do belong to the real numbers, but I don't know how to get it, right? What is excluded? What is not excluded? Okay, so I'm going to share with you a very good technique of finding this. I can actually write down the answer here, but I'll show you first. How do I get that answer? Okay, So let me rewrite this particular function, h of x, right? Perfect. So let's go back to the function h of x, which is given to us as x plus 2 over x plus 5. Now, look here. I could split that 2 in a combination with 5, right? So I could write this as x plus 5 minus 3, right? 5 minus 3 is 2, great. And then divide by x plus 5. Is that clear to you? Now, that means what? That means I could write this as x plus 5 over x plus 5 as one of the terms, right? And the other term being minus 3 over x plus 5. Makes sense? And what is x plus 5 over x plus 5? That is just 1, right? That is just 1, correct? So I could rewrite this as 1 minus 3 over x plus 5. Now, see, the last term, we have a restriction, and now that can never be 0, right? But it could approach to 0, and therefore, we can never get 1 as our value. So we say that y is not equal to 1. You get the idea. So that is how we get the restriction. Here, 1 is your horizontal asymptote, right? Now, the other way which you could see is by comparing the coefficients of numerator and denominator for degrees which they have same, right? Anyway, some of you could also sketch this particular function who are doing at advanced level at this stage. So minus 5 is the vertical asymptote, which is a restriction, right? If I put 0 here, I get 2 over 5, which is positive. So the function kind of like this, right? Not really, because we have vertical asymptote and we have a horizontal asymptote, right? And where is the horizontal asymptote? It is at 1. Do you see that? Yay, that is where it is. Perfect, perfect, perfect. So now we are getting to the right stuff. We see that y is also 0 at x equals to minus 2, right? That makes more sense, right? Perfect. So now let me sketch the graph of this function, which will look like this, right? So, oops, it is actually approaching, it is never equal to, right? So the problem here is as soon as I erase, everything gets erased, right? Okay, something like this. Perfect. Well, that's for you to understand, visualize, okay? So this is y equals to 1, which is the horizontal asymptote, and independent variable can have all the values except for x equals to minus 5, and the dependent variable y cannot have 1 as its value in this particular case. Is it clear to you, right? Perfect. Now let's move on to the next question, which is based on absolute value function. Let's rewrite, which is a of x is minus 2. Absolute value of 5 minus x, right, plus 1. Well, not to get confused, absolute value is always positive. I could reverse it also, right? So I could write this as x minus 5 plus 1. Okay. So sometimes this throws you off. But, it's not that difficult. It's one and the same thing as I've written. Perfect. Now you can see that the absolute value function has a vertex as at 5 and 1. And since it is negative here, it look like this, right? Perfect. And the maximum value will be at 5. And it is going to be 1. And that gives you the domain and range, correct? So the domain for this function is x belongs to real numbers. There are no restrictions. And the range is that y belongs to real numbers, but y is less than equal to 1. Is that clear to you? So sketching also helps. So try to understand all these things. Sketching helps, transformations help. So, but the topic, domain and range, students are doing at different stages. Sometimes it is the very first topic. The first chapter is domain and range, where you have not learned sketching, you have not learned transformations, so it might become slightly challenging. But anyway, now with this, I hope the concepts are absolutely clear. You feel free to send me an email on this with your doubts, and in case you want to learn, nothing better than that. Perfect. So thanks a lot for your time. Feel free to write comments and subscribe to my channel. Thank you once again.